On an average weekday morning, customers arrive at a newsagent independently at the rate of 5 per 10-minute period. Find the probability that at least 5 customers arrive in the next 10 minutes. So it's Poisson, lambda's 5 every 10 minutes. We just want the probability more than 5, or 5 or more, at least 5. So 1 minus less than or equal to 4. That's the table's job. Look it up in the tables. Do your taking away, get an answer. There were 2 marks for part A of the question. Part B. No more than 9 customers arrive between 11 and 11:30. 11 to 11:30 is a 30-minute period. So for part B, we have to times our lambda by 3, because it's 3 times as big, and we're now working with 15. We want no more than 9, that is less than or equal to 9. And again, now lambda is 15, we go to the tables and we get an answer. So there are 3 marks here, 1 for having lambda now 15, 1 for realising it's less than or equal to 9, and 1 for getting it from the tables. We are now told that the period from 11 to 11:30 next Tuesday will be divided into 6 periods of 5 minutes. Find the probability that no customers arrive in at most one of these periods. This is a question again where we're moving into the binomial. We have 6 5-minute periods, and we're looking at our success here is nobody arriving. So nobody arriving, and lambda here is 2.5 for a 5-minute period, which is half of our 5 for a 10-minute period. And if you work that out over here, that is 0.0821. So that's the probability nobody arrives. That's our P. We want less than or equal to 1, because it said find the probability that no customers arrive in at most 1. So we want either 0 or 1. That's our distribution. Calculation for x is 0, which is n choose r, which will be 1. P to the 0, which is 1, 1 minus p to the n minus r. Calculation for it being 1, using the normal binomial probability. Then adding those 2 together, because 0 or 1 were acceptable. So this part of the question, there are 6 marks. So it starts, trying to work out where this one starts, it works under my pen, so it's here. So there's a mark for getting this value here, or realising you have to do that. And there's a mark for stating the distribution. There's a mark for getting the x is 0 answer. There are 2 marks for getting the x is 1 answer, because there is more work involved. And there's 1 mark for adding those together. So you get 6 marks altogether for part C. Part D, by using a suitable approximation, estimate the probability that more than 102 customers arrive next Wednesday morning. We are now looking at Wednesday morning is 3.5 hours, so we are scaling up again. 5 a minute, we're now looking at 3.5 hours, which is 210 minutes, so we're timesing by 21, so lambda becomes 105. So we're dealing with Poisson 105. We're going to use an approximation. We're going to approximate that by the normal distribution, mu and sigma squared. The mean and the variance are 105. So far there's a mark for working out it's 210 minutes. So you're timesing by 21. There's a mark for stating our new distribution. It's normal 105, 105. So 2 marks for that. And we wanted more than 102. More than 102 under Poisson, which is discrete. Because x is over here is normal and is continuous, we have to use a continuity correction. More than 102 becomes more than 102.5. For a normal probability, we need a less than, so we're going to do 1 minus, and here's x minus mu over sigma. The value in the bracket turns out to be minus 0.244. 5 in negative is 1 minus 5 for positive, and there's this 1 minus over here as well. The 1 minus 1 disappear, give you a positive over there, and we get a final answer of 0.596. There were 7 marks of part D. 1 for timesing by 21, 2 for stating the distribution, 1 for using continuity correction, 1 for getting the right sum over here, and 2 marks for getting to the right answer. 7 marks for part D, 6 for part C, 3 for part B, 2 for part A, 18 marks overall. 18 marks overall.